let's start with the introduction first. So basically, what is differentiation? Differentiation is a method of finding the derivative of a function, and there are three techniques to solve differentiation problem, which is derivative of sum and different, derivative of a product function that we use product rule, and derivative of rational functions that we use quotient rule. So you already know what is differentiations. Now we move to the related rate. So what is related rate? A related rate is a problem that involves at least two changing quantities, and the idea is to find the rate of changes quantity by relating to that quantity to another quantity whose rate of change are known, and the rate of change usually respect to time. So there are four applications of differentiations of related rate, which is analysis of functions 1, that is increase, decrease, and concavity. Analysis of functions 2, that is relative extrema, first and second derivative test, applied maximum and minimum problem, and lastly, Ross theorem and mean value theorem. So today, our group would like to having a discussion about the applied maximum and minimum problem. So I will pass to another group members to give a simple example question about the topic applied maximum and minimum problems.
Question 1 is figure show a piece of wire of a length 130 centimeter is bent into the shape of ABCEFG given that BC is equal to DE. Okay, the first question is expressed in terms of y. Second question is show that the area enclosed by the wire is A equal to 200y minus 12y power of 2. And 3H find the maximum area of the shape ABCDEFG. First, first question for question 1 is express x in terms of y. Firstly, the solution is 4y plus 2y plus 2y plus x plus 5 in bracket and plus x plus 5 in the bracket and then plus x equal to 130. And then 8y plus 4y plus 10 is equal to 113. And then we move 10 to another side, which is we getting 8y plus 4x is equal to 113 minus 10. And then 8y plus 4x is equal to 120, and then x equal to 120 minus 8y divided by 4, and then x we getting 13 minus 2y, which is the answer for the question 1. And then question 2 is show that the area enclosed by the wire is A equals 200 minus 12y power of 2. We want to prove it. Let's go. The solution is 4y in bracket x plus 5 plus x times 2y in the bracket, and then getting 4xy plus 20y plus 2y in the bracket 13 minus 2y, and what we get in the mass is 120y minus 8y's power of 2 plus 20y plus 16y and plus 4y, and the final answer for this question is 200 plus 200 minus 12y power of 2, which is we already proved it that we're getting the same answer with the question. Okay, let's move on to the question 3, which is the last question of the question 1. The question is how to find the maximum area of the shape ABCDEFG. Okay, this have 4 steps. The first step, which is A is equal to 200 minus 12y power of 2, and DA divide dy is equal to negative 24 y power of 2. And then d power of 2 a divided by dy power of 2 is equal to negative 24, which is we want to find the fx. For the fx, f prime f, f prime s, and also f prime s, which is double prime. And the step 2, we want to let dA divide dy is equal to 0. And then the next is 200 minus 24y is equal to 0. And then 200 is equal to negative 24y, and we're getting y 25 over 3. And then this third step, which is we want to find the maximum area, we include y is equal to 25 divided 3, and d power of a, d power of 2a divided dy power of 2 is equal to negative 24 less than 0, and it will become the maximum value. And the last step for this question is step 4. We take it a equal to 200 negative 12 y power of 2, and 200 minus 12 is equal to 25 divide 3 power of 2. Divide 3 in bracket for the power of 2. And then 200 in the bracket 25 divide 3 minus 12 in the bracket 25 divided by 3 power of 2, and we get the final answer, which is 2500 divided by 3 centimeter power. That's it.
Now I will continue with the question 2. So the question is, this figure shows a piece of wire of length 200 cm is bent into the shape of triangle ABF and a rectangle CDEF as shown. So given BC is equal to D. The figure is shown above. And then in this question, it will have three questions below, which is express x in terms of y, and then show that the area enclosed by the wire, which is the area is 378y minus 12y. And then for the third one, find the maximum area enclosed. So we will begin with the question A is express x in terms of y. And then we have the perimeter, which is given 200 centimeter. So the perimeter is 3y plus in the bracket x plus 8, and then plus 3y, and then plus again with the bracket x plus 8, and then we plus with x and 7. And then we go to the equation, which is 200 equals to 6y plus 3x and plus 33. And then for if we want to express x, so we take the y to the other side, which is it will be 200 minus 23 and minus 6y, and then equals to 3x. And then for if we need the x to be single, so we move the 3 into the other side, which is it will be 177 minus 6y divided by 3, and then equal to x. And then the x is 59 minus 2y,
Now we will continue with the question B. It says that show that the area enclosed by the wire area equals to 378y minus 12y power of 2. So if we want to get the area, we need to plus both shape of the area. So it will be in the bracket 1.5 multiplied by x and multiplied by 6y, and then plus with the area of the other shape, which is 3y in the bracket x plus 8, and then we close the bracket, and then the equation will be 3yx plus 3yx and plus 24y, and then it will be and then we need to replace the x with what we have done in question 8, which is 59 minus 2y, and then the equation it will be 177y minus 6y power of 2, and then plus 177y, and then minus 6y power of 2, and plus 24y, and then the area is 378y minus 12y power of 2. Now I will continue with the question 2. So the question is, this figure shows a piece of wire of length 200 cm is bent into the shape of triangle ABF and a rectangle CDEF as shown. So given BC is equal to D. The figure is shown above. And then in this question, it will be have three questions below, which is express x in terms of y, and then show that the area enclosed by the wire, which is the area is 378y minus 12y, and then for the third one, find the maximum area enclosed.
The conclusion: the application of differentiation to compute the rate of change using geometry formula. By applying the chain rules method or implicit method, we can count accurately the difference in change that happen. We are really thankful and grateful that we have completed this video presentation in the time given by our lecturer, Madam Isley. This task would not have been complete without the full effort from our group members. Last but not least, we would like to say a lot of thanks to Madam Isley for giving a lot of guidance in this course.